So here's some things that I think we need to measure. I think we need to measure the changes in cell function as a function of various exposure parameters and establish measurements that both show effects and do not show effects. I think that's important if we're going to understand this, and I haven't seen that kind of work being done in very early stage. Another thing that I don't think is established is what happens if you wind up changing heating relatively rapidly. The best explanation of the things we know about with exposure to RF fields is heating. Thermal relaxation times are typically very fast. Thermal time constants for things depend on the size of the object you're heating. They go up. For 1 micron type particles, they're the order of a microsecond. You go up to millimeters, these things increase with the square of the radius, the area you're looking at. So you've got different heating patterns and time constants, and I think these things need to be looked at. And hopefully, in my lab, I've got a lady visiting me from Germany. I think we may be able to do some of these experiments over the next 3 or 4 months. Haven't been done, and we're doing them with thermoelectric devices so that we have something separate totally from what you get from doing this with RF heating. But I think we need to look at which of these things we can establish thermally, and it may very well be that periodic systems like where you establish a coherent pattern that's tied into the cell cycle or tied into chemical rates in here can lead to results that you don't see on a single exposure. And I think this is a very interesting place to look. Well, anyway, that's some thoughts on where to go. One of the things that we clearly came out with when I chaired the National Research Council study was that one needed to take a look at children because you have biological amplifiers in the system who are more likely to show things than others, in addition to what Noam Gandhi had to say about difference in penetration patterns. You've got both effects going. All right, this is a possibility. I talked about transitions between S and T levels. Effects looking at modulated RF. Again, this goes to something that Cindy was saying, the signaling. All right, it's likely, if you look at nerve cells, one nerve pulse to the next is about the same shape, same height, variations are small. All the information is in the pattern. I would not be surprised if the signaling that we're looking at are lower levels is in the pattern of the radiation that we apply. And I would expect that you will see functions of frequency, you'll see functions of modulation. The RF is probably in many cases too fast for the biological processes to respond. It's interesting that temperature can be a demodulator. The temperature you get goes with the square of the electric field as an input. So it does serve as a way from going from high frequency to low frequency, and you can think of the high frequency as a carrier that allows you to penetrate beyond the surface of the skin and affect things at a deeper level. So there's things to be looked at in this area. Signal to noise is an important process. One needs to look at seriously. We know that if you've got enough noise and you don't demodulate this, you won't see this in terms of communication systems. I would be surprised if the biological system doesn't have the same situation, that it takes a signal that it can identify before it does anything. The question is, at what level does this occur? Okay, adaptive processes and long-term repeated exposures are things that haven't been looked at. On the aplesia, for example, we found our first microwave pulse had a bigger response than the second one and the third one if we separated them by about 5 minutes each. You got an adaptive response. And there's no surprise in that for people who've studied biology, but I don't think that's been explored in this field. All right? Coherence. You talked about dirty electricity here. That would go exactly the opposite of this. All right? It would say that the thing about 60 hertz fields, for example, is its stableness, its coherence. It would be the thing that would lead to the ability of a biological system to react to that. So I think data you presented earlier is very interesting because that I'm not sure where that comes about. It may be in things like stochastic resonance and so forth. But I think they're very interesting things to look at. We talk about stress being both positive and negative. If you see a tiger coming and you run faster because you're stressed out, that's probably a good thing. On the other hand, if you're overstressed, you wind up a small additional stress on this, winds up like the straw that broke the camel's back. So I think the various people are going to have different sensitivities at different times. And the question is, what else is in the background? And what bothers somebody at one time is not going to bother them at another. And how do we look at that? Then finally, I'll talk about, let's go on to that. The statement, first of all, we don't live in a risk-free world. My feeling about this is it's not safety standards. We should be talking about relative risk. We can't prove something is safe against all those experiments we haven't thought of yet. You can't prove the negative on some of these things. The question is, where do you put this, and then how do we want to deal with it? And a lot of that has to do with philosophy. For example, and here's a table of risk with regard to getting cancer in terms of some stuff was done. Wait a second, how did I get to that one? The wrong place. That starts at the wrong place here. I'm down, okay. Down to the bottom. Let's go to this table. This is number of days lost. All right, the cancer table, I wound up copying the wrong section. But basically, you find that there are a lot of different sources for this. And the question is, given what we know, where do you get it? Now, you'll get a chuckle out of this on this one. I gave this talk in Japan one time, and I didn't know whether the students understood me or not. And so there's a dead silence after the end of the talk, and I'm figuring what's happened. And then there's a kid in the back of the room. He says, "Where did you get that data on an unmarried male?" I figured that was the fun one on this. But I think the point is that we don't live in a risk-free world. We have reasons, if we're going to have cell phones at all, to have numbers that the cell phone manufacturers can manufacture to. They've got to know whether they can do something or not. Now, where you set that level, I'm quite sure various people have totally different numbers too. But if you want to have them, you've got to have some sort of number that says it's either okay or it's not okay. On the other hand, I think it's much easier to change the table of risk in terms of what do we know at this stage of the game. And you can start with something and we'd say, well, if I talk about the electric chair, that clearly goes to the top of this list. If I talk about cell phones, when I'm hand-holding it here, the number is probably different. If I talk about the numbers that you get from cell phone towers, the number is probably different. The question is, where do we pick those numbers? Under what basis? And let me go back to a question of philosophy. When I first went to the Soviet Union in 1984, the standards in the US were 10 milliwatts per square centimeter. The standards in the Soviet Union were 10 microwatts. Now, we sat at a long table that's about the distance across the front row here. And after, and everybody had to propose a toast bottom up of vodka, all right? After the 10th one or so, you began to learn some fairly interesting things. And incidentally, I didn't touch vodka for the next 3 years. But what came out of that was that although the Soviets had a standard of 10 microwatts, it got violated all the time. Nobody ever sued the Soviet government for violating the standards. And so the two standards had totally different meaning. One time you'd say they're 1,000 times safer than we are. On the other hand, if you violated the standards in the US, you could get sued for megabucks. In there, nobody got sued for anything. And the actual fact was that they were violating their standards right and left. And people were actually getting exposed to a lot higher exposures than we were. So I think one needs to look at the whole process in terms of what this is. And my own point of view is that we need have levels that we set in terms of saying, okay, this is something a manufacturer can or can't do. And then secondly, we ought to provide the public with some data that we have on risk that can be updated more easily and say, all right, given this information, you take responsibility at this level, and the public takes responsibility at another level. Now, what those levels are, we can argue about and disagree about, but I think that we do need to separate the problems. Okay, that's the end. Thank you.